Okay. So last class we read about Kepler's laws of planetary motion, and it is very important concept, important topic. And in the first law we have seen, if you remember, so we have seen that it is the first law of elliptical orbit. Okay. And finally we have found the eccentricity formula, and we have seen how the eccentricity energy they are related and what kind of orbital structure can become. Okay. So basically we get elliptical orbit. So what is the range of this value? So what is the values of this eccentricity and capital E energy? That also we have discussed. And also we have seen for eccentricity greater than 1, equal to 1, less than 1 and 0, how our structure is modified. Okay, the orbit gets modified. So basically we can say that our orbits are elliptical in nature. This is what first law talks about. Then coming to the second law of Kepler's second law. So that is known as the laws of period. Okay. So today's topic is the laws of period. Okay. Period means time period. Okay. So square of the time period of revolution of a planet around a sun is directly proportional to the cube of semi-major axis of the ellipse. That means what? That means that t square is proportional to a cube. T is the time period of revolution of a planet around sun. Okay, suppose this is sun and planet is revolving in an elliptical orbit. Okay, let's say this is the sun here and the planet is revolving around the elliptical orbit. So the time period, the square of the time period is proportional to the cube of semi-major axis of the ellipse. Am I audible to all?
Yes.
So this is what we are going to find out. Basically, this is the third law. Okay, this is also known as Kepler third law. So what is the law telling you? The square of the time period of revolution of a planet around sun is directly proportional to the cube of semi-major axis. Okay, that is denoted as A of the ellipse. So you must be knowing that this one is your semi-major axis and this one is your semi-minor axis. Okay. So basically from the first law of planetary motion, we know that for an elliptical orbit, the equation of orbit, what is the equation of orbit that we have already deduced in our first law? So from first law of planetary motion for elliptical orbit, the equation of orbit. You can see equation number 10. Last class, go to your notes, and see equation number 10. Okay. So from equation 10. See, these things are a continuity. Okay. So we have to continue our first law and then we will continue. So the equation number will also continue. So the last equation was equation 16, where you found the energy. That is also required. Okay. So similarly, you see equation 10. So you will find that equation is L by R is equal to 1 plus E cos theta minus theta prime. Actually, equation 10 is not this exact equation. It was L square by mk whole divided by R. That means your lattice rectum. Here in this equation number 17, This L is called latus rectum. I've already explained you what is latus rectum. Okay, that is a line segment which is perpendicular to the axis of parabola through which the focus and the end points that they lie on the parabola. Okay, so it will pass through the focus and the end points will lie on the parabola. That is called latus rectum. And that latus rectum I have written in equation 10 as capital L square by mk. Okay, so similarly, E is called your eccentricity. So in equation 10, I have written E as L square A by mk. Okay, so I have written the general form, that is L by R, that is equal to 1 plus E cos theta minus theta prime. So here you know that L is your lattice rectum, and if you compare, it is equal to L square by mk. Similarly, E is called eccentricity. Eccentricity factor will decide whether the orbit will be circular or elliptical, and this is equals to 1 plus 2L square E by mk square root over. So these things we have already deduced in the last class. Okay, is that clear?
Yes, sir.
Is it audible to all, visible to all? Shall I proceed? Is it
Yes,
audible?
sir.
Okay. So now from this equation 17, we have to find out the cases for perihelion point and aphelion point. You must be aware of the word perihelion, aphelion. Perihelion means it is the nearest point from the sun. Earth इतना close आ सकता है sun के पास. Okay, that is the nearest approach of Earth to the sun, and that is called perihelion point. Aphelion is just the opposite of that. That is the farthest point from the sun. So how will we find out these two things from this equation 17? So basically, we will take the range of this theta minus theta prime. So what value will this theta minus theta prime have? So that cos of that value will be maximum. So it is obvious that cos 0 is 1. So that is the maximum value cos can have, cosine function can have. So the condition arises here is when theta minus theta prime is equal to 0, this implies cos 0 is equal to 1. So this is the maximum value it can have. So here what happens? Here R will be minimum. What is R? R is the distance between Sun and Earth. For example, let's say this is the elliptical orbit. Let's say that our Sun is situated here. Okay, and Earth is somewhere here. This is your Earth, and it is revolving around it. So you know what is semi-major, semi-minor axis. So now the Earth, if it is here, then this distance is called your R. All right. So what is the minimum point? If R will be minimum, this implies that this is called perihelion. Perihelion point. That means nearest point of Earth and or nearest point between Earth and Sun. Between Earth and Sun. This is called your perihelion point. That means let's say this point. So as soon as Earth reaches this point, immediately it will be drifted with a larger velocity and it will move away from Sun. So velocity close to Sun will be little bit larger than the velocity at this point. Gradually, when it approaches and comes closer to Sun, then immediately again velocity gets drifted and the sun, Earth will go away from Sun once again. So in this way, all the planets are revolving around the Sun. That means you cannot say that the speed of any planet around the Sun in elliptical orbit is same throughout. Okay, but the speed is not a huge difference. Very small difference is there, but there is a change in speed. Okay, so in this case, we can say let R minimum is R1. So L by R1 is equal to 1 plus E. So this implies R1 is equal to L by 1 plus E. This is equation 18. Okay, so we found this R1, that is the minimum point, that is at perihelion point. So this is the equation for perihelion point. Okay, that means what? That means, for example, let's say this one, when Earth is close to Sun. Am I audible to all?
Yes, sir.
This point when Earth is close to Sun is called your R1, and when this is away from Sun, let's say somewhere around here, that is the farthest point for aphelion, that is R2, and we know that this completely it is called 2A. That means this part is your A. This is called semi-major axis. Similarly, from this point O to this point, let's say this point is A, this is B, this is C, and D. So OD and OC is called semi-minor axis. Okay, and completely AB is called major axis. This is called minor axis. Understood? These things you must be knowing. I've already discussed also. So this is the condition when cos theta will have maximum value. So it will be perihelion point. So now let us see what happens in case of your aphelion point. So next is when theta minus theta prime is 180 degree. So this implies cos theta minus theta prime is equal to minus 1. So this is the minimum value. Okay. So in this case, what happens? R is maximum. So this point is called aphelion point. Okay. That is farthest from Sun. Farthest from Sun. So what happens here? I can write L by R2 is equal to 1 minus E. This implies R2 is equal to L by 1 minus E. That is equation 19. Okay. So from these two equations, R1 and R2, if I take the sum of that, adding R1 and R2, what will you get? R1 plus R2 is nothing but the complete distance, that is 2A. Look at this figure. It is 2A, isn't it? So now just do the addition, simple addition. So on adding, you'll get this is L by 1 plus E plus L by 1 minus E is equal to 2A. Okay. So if you solve it, you will get A is equal to L by 1 minus E square. This implies A is equal to, we know that this lattice rectum is called your L square by MK full divided by 1 minus, what is your E? And this is E square. So that root over part will be cancelled out. So you are left out with 1 plus 2EL by MK square. Okay. So if you solve it, you will get final expression
यहाँ
is
पे
minus,
A है 2A
थोड़ा loudly बोलो.
सर यहाँ पे 2A कैसे आया
This 2A.
यस
See this figure. What is your R1? It is the distance of Earth from the perihelion point to Sun. Okay, that is R1. And when Earth is at B point, that distance from Sun is R2. If you add R1 and R2, that is completely AB. So AB is what? 2A, because OB is semi-major axis.
यस
Okay.
यस यस
So if you substitute everything, so you'll get minus K by 2E, and final expression of your E is equal to minus K by 2A. Okay, this is equation number 20. Is that clear? So if anybody asks you, whatever be the planet, wherever it is revolving around any massive object, so on what factor the total energy of the planet is depending? The total energy of the planet is depending on the semi-major axis, or you can say major axis. That means that कितने distance में वो planet present है. There is the appropriate distance of the planet from that massive object. If slight difference will take place, then there is a probability that either the planet will fall into the, or it will collide, or it may go away. Okay, whatever we are discussing with context to two body problem. Okay, so here I can say from this expression that the total energy of planet depends upon the major axis. Okay, understood? Any doubt up to here? Okay. So now what we will do is we'll find out the time period as our laws says, laws about time period. So let T is the time period of planet, okay, or time period of revolution of planet around sun, time period of revolution of planet around sun. So what is your area swept by the planet, or you can say area of orbit? Let's say it is capital A, that is equal to small change in area. Okay, so that is equals to dA by dt into dt, and this integration goes from 0 to t. Okay, maximum time period t, and this is very simple one. So when you solve this equation, you'll get from 0 to t, so dA by dt. So what is your dA by dt? That represents your aerial velocity. Okay, so aerial velocity is given as dA by dt, that can also be written as half r square theta dot multiplied with dt. Equation 21. So this dA by dt is called your aerial velocity. Okay, aerial velocity. And from this equation, we know that like we have to substitute the value of theta dot, and we know that the angular momentum is given as mr square theta dot. Okay, so you can write directly that this is equals to 0 to t half. This is your r square. So r square theta dot. That means L is equal to, actually you know that L is equal to m r square theta dot. So what is your theta dot? It is L by mr square. So I have to just substitute here L by mr square. So this r square gets cancelled, and this is dt. So when you solve it, you will get L by 2m, and this is integration of dt 0 to t. Is that clear? So now if you just substitute this limit, the final expression of area of orbit, that is given as L by 2m, and this is integration of dt is t, so substitute the value, so you will get Lt by 2m. Okay, Lt by 2m, equation 22. Yes or no? Simple integration. So you found area of the orbit, that is when the planet is revolving around the sun. Is that clear?
Yes.
Okay. But in a simpler form, we know that area of orbit, we know area of orbit is given as pi a b, because if you see the this diagram, there is pi r square, isn't it? Pi r square. So your r is not fixed. So once you will take for perihelion point, again you will take for aphelion point. So once you will take r1, then r2, or you can say a and b. So pi r square can also be written as pi a and b. Pi multiplied with, this is the semi major and semi minor axis, pi ab. So now you equate this one, equation 23. So if you compare, on comparing equation 22 and 23, what you will get, that pi ab is equal to lt by 2m. So from here you have to find time period. So find out. So 2 pi mab by L. 2 pi mab by L. See, so time period is depending on the angular momentum, because all other terms are constant, isn't it? 2 pi constant, m is constant, a, b, that is also constant for a particular planet revolving around sun. Okay, so t is depending on, inversely it is depending on angular momentum. So give this equation 24. Okay, is it clear? But the question arises here is, you know that even if you study your relativity also, that then also you'll come to know that your planets which are revolving around the sun, they never meet at the same point after one complete revolution, because our sun is not fixed, neither the planets are fixed, but they follow elliptical path. That means our A and B, they are continuously changing and they are adjusting in such a way that planet will not fall into sun or not go away from the sun. It will revolve around the sun. Do you understand that? So classically also the same thing, these things are correct. And if you look after your general theory of relativity or special theory of relativity, then also this thing holds good. So that means that what is the relation between this A and B? One thing we can notice from here, that this B is depending on the angular momentum and also on AB, but AB remains constant for a particular time period. That means for, let's say our sun is now here, and let's say suppose our earth is somewhere around here. So when earth will complete one revolution and again come to this point, for that time period, this A and B remains same. Do you understand that? When again earth will start rotating after 1 year, let's say 3rd March 2023, then it will not, it will follow the same elliptical path, but not the same point. Okay, because earth is revolving spirally like this around the sun, and even sun is also moving around the Milky Way galaxy. So these things and this classical mechanics also, both the things are correlated. If it is correlated, it holds good. So that you can say that the time period also depends on A and B, semi major and semi minor axis. So what is the relation between this A and B, that we need to find out in case of a ellipse? Is that clear?
Yes.
Any doubt up to here? Any doubt? Shall we proceed? I'm not getting any response from other students except Roshni. What about others? Are you able to hear me?
Yes, sir.
Yes.
Okay.
Yes, sir.
Okay. So T is equal to 2 pi MAB by L. So in case of ellipse, let us find out what is the relation between A and B. So here we know that since B is equal to A 1 minus E square, root over of 1 minus E square. Okay, so this is the relation of B with A and eccentricity. So just substitute this E value here. So if you substitute and do the mathematical calculations, you will get A root over of 1 minus, and what is your E square? E value is root over of 1 plus 2EL square by MK square. So do the squaring of that. So root over is cancelled. So you are left out with 1. And if I bring this minus, so this plus becomes minus, then it is 2EL square by MK square. Do you understand that? If I put bracket here, then this is plus. I have removed the bracket. Okay. So what I have written is, I have just removed the bracket, and in case of your plus, this becomes minus. Is that clear to all? So this B is equals to root over of minus 2 EL square by MK square. Is that clear? Okay, A is here. Is that clear to all?
Yes, sir.
Anybody having any doubt up to this? Satyabrat, any doubt?
No, sir.
Suhana?
No, sir.
Suhana? Roshni? Okay. So let's proceed then. So B is equals to this. Okay, now what we have to do is we have to substitute this values of E. Okay, you can see your equation number 20. So if you substitute equation 20 here, then what you will get? This is A root over of minus 2 by mk square L square as it is, and your E is equals to minus k by 2A. So it is minus k by 2A. So minus minus becomes plus, 2 gets cancelled, and k. So if you do all this cancellations part, then you are left out with A root over of L square by mka. Okay. So further, if you do the calculation, then let's see what you're getting the relation of B with A. So this implies B is equals to A by root A. So bring this root A outside, and other things like L by root over of mk as it is. So this is root over of A L by root over of mk. Give this equation number 25. So use this equation 25 in equation 24 in the case of time period. So what you will get? Using 25 in 24, T is equals to 2m pi A, and B is what? Root over of A L by mk root over, and one L was there here. So it will be cancelled. So you will have 2 root over of m pi A to the power 3 by 2 whole divided by root over of k. Okay, so as we know from the law that t square, we need t square, and this is a cube. So it is clearly visible what you have to do. So simply do the squaring. So if you do the squaring, what you will get is 4 pi square m a to the power 3 whole divided by k. So you can see that if we give a term, let's say some constant, let's say that constant is c a cube, where c is a constant, okay? That is 4 pi square m by k. C is constant, that is equals to 4 pi square m by k. So this implies I can write t square is proportional to c cube. Okay. So equation number 26. So this is Kepler third law. Okay, square of the time period is proportional to the cube of, sorry, this is a cube of your semi major axis. Okay, do you understand up to this? Any doubt? Anybody having any doubt?
No, sir.
No, sir.